so as a refresher, going over all the stuff that we just covered in these sections up above on the notes, what was the first particle to be discovered? Was it the proton, the neutron, or the electron? The first one? If you're not sure, look at this. Remember we had the little sentence, tight elastic, rubber pants cause nasty body odor. So T, E are associated together, meaning Thomson discovered the what? Electron. Good. And then while we're here, we'll do RP for Rutherford discovered the what? Proton. And then CN, Chadwick discovered the neutron. And then BO, Bohr added orbitals to that model. So that goes in chronological order. That's why we started way up here with these guys and kind of worked our way down all the way to the quantum mechanics model, even though that wasn't a person. All right, so I'm going to ask again, what was the first particle to be discovered? The electron, thank you. Who discovered the electron? Thomson. The location of electrons, or the location of an electron within the atom, we're going to describe this as either inside the nucleus or outside the nucleus, but don't just write outside, because that tends to confuse students when you go back and you look at your notes later. When you look at it and you say location outside the atom, no, the electrons are not outside the atom, they are outside of the nucleus, but still within the atom. Make sense? So location of the electrons will be outside the nucleus. And then the charge of an electron, is it positive, negative, or neutral?
Negative.
Negative, thank you. I'm going to abbreviate that with just a negative sign. The symbol then that I use for electron is just an E with a negative sign. And then the actual mass of an electron is 9.11 times 10 to the negative 31st power kilograms. So 9.11 times 10 to the negative 31st kilograms. If we're looking at that number, is that a really, really big number or a really, really small number? Super, super small. I'm going to skip relative mass for now, and we'll come back to it once we have all of these filled out. So second particle to be discovered, what was that? The proton. Who discovered the proton?
Wait, what's the real?
I'll go back to it, don't worry. Who discovered the proton? Rutherford discovered the proton. The location of the proton. So again, your options are really inside the nucleus or outside the nucleus. Where's your proton located? Inside the nucleus. And then the charge of your proton is what? Positive, negative, neutral? Positive. So we abbreviate a proton as P with a little plus sign. And then back over to the actual mass. Again, I skipped the relative mass, and we'll talk about that after we do the neutron. The actual mass of a proton is 1.67 times 10 to the negative 27th kilograms. And then again, leaving relative mass blank until after our last particle, which we said was the what? Neutron. Trying to pick a different color here. This one's good enough. Neutron. And who discovered the neutron? Chadwick. The location of the neutron, is it inside or outside of the nucleus? I heard mumbles. Inside, perfect, thank you. And the charge of the neutron, it is a neutron, meaning it is neutral. So there is no charge. And the way that I abbreviate it as a symbol is by doing an N with a little 0, like N naught. So electrons, protons, and neutrons, if you use those symbols, you will never be confused on what the charge is. A lot of students try to say that a neutron is negative, and I get it because that N connection is there, but neutrons are neutral. And then the mass of a neutron is the same actual mass, and it's going to be the same relative mass as a proton. So 1.67 times 10 to the negative 27th kilograms. So these two numbers are the same. When we're looking at any of these, all three of these things are really, really, really small numbers. So instead of actually using their actual masses at any point in this class, we refer to their relative masses just to make it easier on us. So if we're looking at these, can you tell which number is bigger, 1.67 times 10 to the negative 27th or 9.11 times 10 to the negative 31st? Which one is a larger number? The one on the bottom. Okay, so 1.67 times 10 to the negative 27th. If you're not sure how to conceptualize that, and this was kind of what I was getting at with our scientific notation, like just understanding the bigger picture of it, if we have a negative exponent, that tells me that my number is going to be small. And specifically in this case, if it's negative 27, I'm moving my decimal 27 places to the front here. So this would be one spot taken up with the 1 and then 26 zeros in front of it. Versus this one, I would move it one spot taken up with the 9 and then 30 zeros in front of it. So it's the difference between 30 zeros and 26 zeros. Does that make sense? So these numbers are bigger than this one. So we're going to assign the relative mass for protons and neutrons to be just 1 for each of those. So the proton has a relative mass of 1, and the neutron also has a relative mass of 1. So what we're taking this as is that an electron has such a small mass when compared to the proton or the neutron that we just consider it 0. So we pretend that the electron has no mass at all. Even though we know it technically does, we act as though it doesn't. Good? Can you wait till we're done with the first page? All right, the section down here is kind of just summarizing all of the stuff that we've been over, so I'll kind of go through it quickly. It says inside the nucleus, it is composed of two things. What two things are inside the nucleus? Protons and neutrons. If you have positive charges and neutral charges combined in this mass in the center of your atom, the overall charge of that nucleus is going to be positive because you don't have negative charges in the center to balance it out. So it overall has a positive charge. The nucleus is very dense. It has an extremely small percentage of the total volume, meaning that it doesn't actually take up that much space within the atom, but 99.97% of the atom's mass comes from the nucleus. And then outside the nucleus is mostly empty space through which the electrons travel. Overall, if it's made up of just electrons, what type of charge would outside the nucleus have? Negative. So So this space outside the nucleus, that is what we refer to as the electron cloud. And then how they fit together is that first, electrons are held within the atom due to their attraction to the nucleus. So we do have that attraction between the positive nucleus and the negative electrons surrounding it. So they're attracted to each other. Neutrons help to stabilize the nucleus. They act as pillows to separate the positive protons. So we are able to have multiple protons in close proximity to one another because we have sort of these buffers of neutrons around them. Too many neutrons can make the atom radioactive. We'll talk about that way later in second semester. And then this part is super important. I underlined the word atoms. I'm going to highlight it as well. Since all atoms are electrically neutral, so if you see that vocabulary word of atoms, what that means is electrically neutral, which means that our positive charges equal our negative charges, or they are canceled out or balanced out, or however you want to think about it. So what that means in terms of our subatomic particles is that the number of protons will equal the number of electrons in a neutral atom. So since all atoms are electrically neutral, we're going to say the number of protons equals the number of electrons. Or the number of positive charges equals the number of negative charges. So if it says atoms, that's what tells you that it's neutral. If it says particle, it's kind of ambiguous and it might go one way or another. If the number of protons does not equal the number of electrons, that means that that particle has a charge. And you find what the charge is by taking the difference between the two. And a charged particle is called an ion. So I'm going to give you an example of that before we move on. So ion is spelled I-O-N. So what I mean by that is if I have, let's say, 5 protons. Don't flip your page yet. Write this just at the bottom. If I have 5 protons, and let's say I have 5 electrons, my number of positive charges equals my number of negative charges, so there is no charge. That would be called a neutral atom. Make sense? If I have 5 protons, and I have, 3 electrons, my positive charges outweigh my negative charges by 2. I have 2 more positives. So I'm only able to cancel out 3 negative charges with a remainder of 2 positive charges. Do you see how I got that? So that means that this ion is left with a charge. So this would be a +2 ion, or an ion that has a positive 2 charge. And then if I have, let's say, 5 protons and 8 electrons, how would we call that one? Which one is winning, the positive side or the negative side? The negative is winning, so I know it's going to be a negative charge. And it's going to be a -3, so a -3 ion. A positive ion is what we call a cation. I'm going to keep throwing these words in here for us. And then a negative ion is what we call an anion.
An onion?
I know, it looks like onion. So negative ion is anion, positive is cation. Notice in each of these examples, I had 5 protons in each one. We are not changing our number of protons when we talk about specific atoms, and we'll talk about why in just a second. But the way to get a negative ion is by gaining electrons, and the way to get a positive ion is by losing electrons. It will make more sense once we're actually talking about specific elements, but I'm going to stop this one here.